On our test review sheet for lessons 3.7 through 4.4 and review of chapters 1 and 2, this is problem number 2, and I want to work through this one for you. This is the directions here are to graph this quadratic inequality. You notice that we see x and y, and that should give you a little clue that our answers, in order to answer this properly, our answers are going to be x, y coordinates. We need both x and y to be able to plug into this to see if those x, y coordinates actually make this true. And so the final answer after we're completed will be shading to represent all of the x, y coordinates. If there is a solution, it will be all of the x, y coordinates, and there will be so many that we can't list them all. They go on infinitely in a certain direction. There'll be a certain area. And so some people get a little confused on when do I shade inequalities, or when do I just state the answer as an inequality, like x is between certain numbers. Well, if you see x and y in the inequality, you need to come up with ordered pairs. And you will come up with when you find out where those ordered pairs are, you'll shade to indicate all the area containing the ordered pairs that would make this particular statement true. But first we need to come up with the parabola. And so you might think of this in terms of the equation form. This is a little bit of review of what we've done in the past. We've been taking quadratic equations and coming up with the graph, and that typically starts with finding the AOS so we can find the vertex. So here's using the AOS formula. You could also change this to vertex form if you like, but I think in cases like this, when the number in front of x squared is not 1, it's probably just as easy to use our AOS formula. So to find the AOS, opposite of b over 2a, so that's going to be the opposite of negative 2 over 2 times 2, and negative 1/2 would be in the parentheses, negative 2 over 4, but the opposite of negative 1/2 is positive 1/2. So we have symmetry around the line x equals 1/2. I won't draw that, but you see that's going to be our symmetry line, and on that line of symmetry will be the vertex. So we know the coordinate, the x coordinate of the vertex is going to be 1/2. We need to find out what the y coordinate is, and we'll do that by plugging 1/2 back into this particular function. 2 times 1/2 squared minus 2 times 1/2 minus 3. It's 2 times a fourth minus 1 minus 3, 2/4, which is 1/2, minus 1 minus 3. That gives us negative 3.5. Okay, and I'll erase this to give myself a little bit of room, but I just wanted you to see how we got the vertex. And you don't have to really come up with a lot of points for these parabolas. We're just going to come up with a rough sketch. We do need the vertex, so 1/2, 3.5, negative 3.5. And we'll say that's right there. We can use the y-intercept. That's going to be negative 3. And a matching point because of symmetry. And that's really pretty much all we need. You could do another input if you like. You could put in 2. That's pretty easy to do. 2 squared is 4. 4 times 2 is 8. Minus 4 is 4. Minus 3 is 1. So 0.21 should be on this graph, and that's 1.5 units away. So we can match that up. So you can get some other points pretty easily, but that's sufficient. Now I'm going to look at the inequality, and since it does not say or equal to, I'm going to do a dotted parabola. Okay, so once again, when you see x, y, like you do in this problem, you're coming up with ordered pairs, x and y, all of the ordered pairs that would make this true. And we're going to have to indicate those by shading. And so looking at the symbol greater than related to this parabola, we could say that greater than always means above the line when we were dealing with lines, and that same idea holds true with parabolas. Above would be in that area above both of these parts of the parabola. Below would be the underside or the outside or the parabola. That's what less than would do. So greater than would mean that I'm going to shade inside the parabola. And so all of these xy coordinates that fall in the shading should make this true. That's really what we're saying. And so we can test, and the easy test that we've talked about is the origin. So the origin falls inside the shade, so when I plug in 0 for y and 0 for x, I should get a true statement. But I'm going to go ahead and do that just to give myself some confidence that I have shaded correctly. So y is 0, this would be 0, minus 0, and then minus 3. And I just want to know, when I let x and y both be 0, do I get a true statement? And I do. So that tells me that I must have shaded the correct area, because 0, 0 is in the shading, and the shading represents all of the solutions. So any xy that you choose in the shading will make this true. Okay, so that's your final answer for number 2. Now you notice on number 3, this is not an inequality in 2 variables. It's just one variable. So now my answer is just going to be x's, numbers on the x-axis, just the x-coordinates from a graph. And in particular, since this is going to be a parabola that opens up, I'm going to be looking for those x-coordinates on this graph that fall below the x-axis. That's what less than 0 means for this parabola that opens up. So again, hopefully you see the difference between number 2 and 3. Number 2 is 2 variables, so I need to shade all of the xy coordinates that satisfy the inequality. This is just one variable, so now I'm only interested in numbers. If there are solutions, it's going to be just the x-coordinates, just the numbers on the x-axis that will make this true. And the parabola is going to help me get the answer. So once again, we need to sketch a parabola, but in this case, since I'm dealing with solutions that fall around or on the x-axis, I need to know exactly where this parabola, if it does cross, where does it cross? So let's once again treat this like an equation and solve it, because the solutions to a quadratic equation are also the x-intercepts for the graph. And fortunately, this factoring is, to me, always the easiest way to solve a quadratic equation. So the factors of -6 that add up to 5, and so the factoring leads me pretty easily to the solutions. There are 2 x-intercepts. X is -6, 1, 2, 3, 4, 5, 6, and x is +1. So this parabola that opens up has to have a vertex down here somewhere. It's going to cross the x-axis at those 2 points. So let's find out where the vertex is. Once again, you could do opposite of b over 2a. There's no problem there. You could find the midpoint of these 2 red dots. They are 7 units apart, and that means it's 3.5 units to the midpoint, and so that would make the x-coordinate of the vertex -2.5, which you would also get if you use the opposite of b over 2a, -5/2. So we know the x-coordinate of the vertex is -2.5. So to get the y, once again, just a repeat of our last problem, we're going to put -2.5 in for x and see what the y coordinate is. Okay, so let's grab our calculator. Negative 2.5 squared plus 5 times negative 2.5 minus 6. And we get negative 12.25, negative 12 1/4. So I'm going to go ahead and make my y-axis only in 2's, just so that I can make this fit. So here on this symmetry line at negative 2.5, I'm going to go 2, 4, 6, 8, 10, 12, and then just a little bit lower. So for these, we do have an easy graphable point. We have the y-intercept at negative 6. So we might as well go ahead and use that to draw through. And because of symmetry, we can match that up. So here is our parabola. Now the one thing I am going to change is these x-intercepts. I've made them solid just to find out where they are, but as I look at the inequality, since it does not say or equal to, these really should be open circles. They would stay solid if the inequality was or equal to. Alright, and so here is my parabola. And now I'm looking at the original inequality, and it says, alright, give me all of the x coordinates from this parabola, but I only want the x coordinates from the parabola where it is below the x-axis. It is below the x-axis, obviously, here. And those x coordinates that represent this part of the parabola are only right here. For example, this point right here is negative 5, negative 3. Okay, negative 5 is one of the x's to go along with this one, and so forth and so on. All of the x's that are x coordinates for the graph in this part, this below the x-axis part, there, I'll just shade the x-axis to represent those. So my answer is going to be all of these x's, all of the x's that fall between negative 6 and positive 1. And so we'll state it like this: all x's such that, and here's one of those between statements. And that would show all of the x's, x coordinates or values for x, any of these values for x that we choose. And if you wanted to test it, just pick one. Negative 1. If you plug negative 1 in for x in both cases, negative 1 squared is 1, minus 5, minus 6. 1 minus 5 is negative 4, minus 6 is negative 10. That is definitely less than 0. So that's good. Any number for x in between will make this true. It will satisfy this inequality. And so that is your final answer for number 3. So I hope that helps, and study hard, work hard preparing for this test, and I'll see you next time.